These are the two simple questions that appeared in NEET 2020, two different papers at that year. The first question is, the wave nature of the electrons was experimentally verified by what? See, the thing that we need to understand is, it is de Broglie who explained that theoretically that electron could be having a wave nature whose wavelength equal to lambda by p, that equal to mv. That is theoretically presented by de Broglie. But that is experimentally verified by division and Germer's experiment which is done with electron, and it is proved that that electron has properties like exhibits properties like diffraction, bends at the obstacle, scattering. So these things has verified that electron, who is like a particle, has a wave nature. So this is proposed by de Broglie, but that was actually experimentally verified by division and Germer. That's the answer for the question. Let's have a look at the second question. What does the second question says? An electron is accelerated from rest through a potential difference of V volts. De Broglie wavelength is given for you. What is the potential difference is? As I am telling, as per de Broglie wave equation, lambda equal to h by p, that equal to mv. You need to express it now in terms of voltage. Momentum p and kinetic energy is related as Ke equal to p square by 2m. So in the place of p, I can write root of 2m times of kinetic energy. So in the place of momentum, we can rewrite lambda equation as h by root of 2m times of kinetic energy. This kinetic energy is being provided to the electron with the applied potential difference. Thus, I can take the very definition of a potential difference as work done in bringing unit positive charge from infinite distance up to a point. That implies work done equal to VQ, because that's an electron, that is VE. This work done is converted as a kinetic energy and electron moves. So in the place of kinetic energy, I can write potential difference applied into charge of electron. It implies the value of the lambda will become what? In that case, h by root of 2m VE. So if you substitute all these values of Planck's constant 6.6 into 10 power minus 34, mass of electron 9.1 into 10 power minus 31, charge of electron 1.6 into 10 power minus 19, and calculate, it can be found that lambda in angstrom can be expressed as 12.27 into square root of V when you substitute all the values. I am not doing that calculation here. You please confirm and verify, and this is even being considered like a standard equation in dual nature of the radiation and matter. So once after knowing this, we can substitute the data. Lambda in angstrom we have to find out as what? Lambda is given for you as 1.227 into 10 power minus 2 nanometer, that is 10 power minus 9. If I have to express it as an angstrom, I have to multiply with another 10 power minus 1. So to compensate that, I have to multiply with 10 power plus 1. Everything else has to remain same. 1.227 into 10 power minus 2. This together now becomes angstrom. This minus 2 becomes minus 1 because I have multiplied with the 10 power plus 1. So 10 power minus 1 angstrom. That is 0.1227 angstrom. I have just converted the nanometer into angstrom. Now let me substitute that value here. Lambda is 0.1227 equal to, as per the equation, 12.27 by square root of V. So this will become 12.27 into 10 power plus 2, equal to 12.27 by square root of V. These two will cancel. So square root of V can be further expressed as something like this is 12.27 into 10 power minus 2, not plus 2, right? This is 12.27 into 10 power minus 2. So 10 power minus 4 equal to 1 by V. V equal to 1 by 10 power minus 4, that is 10 power plus 4 volts. So you shall apply a voltage of 10 power 4 volts for these things to happen, right? This is how we have to solve the problem. Thank you for watching.